Hi everyone, and welcome back. In this video we're going to be talking about cylindrical tunnel shapes. So in order to complete this, we're going to be drawing on some of the information that we already went through when we looked at tunnel shapes in rectangular prisms, but also what we looked at yesterday to do with calculating surface area of cylinders. So it's going to be quite similar to what we did yesterday, where we separated into a top and bottom views, matching views, and the wraparound side. But on top of that, because this is a tunnel shape where we have a hole cut through the center that runs all the way through, that means we've got a little more surface area exposed on the inside. So you can see that I've already separated this into outside plus inside. We will have to do calculations for both. So focusing on the outside first of all. So just like the standard cylinder, when we look at the outside, we've got the top and the bottom, which in this case is not just a circle, but instead it's a ring shape or a window with a circle missing a circle, and then of course the matching bottom that we can't see underneath there. So we've got the matching top slash bottom that we can calculate all together, plus we have, just like the standard cylinder, the wraparound side on the outside of this. So this wraparound part right here, which if we were to cut and lay flat, would actually just make a great big long rectangle. So top and bottom plus side. So the side, like I just said, if we cut it up, it would just make a big long rectangle. And the top and bottom, like I said, if we look on straight down from the top, we would see a circle, but it would be a circle with another circle missing in the middle, like a little ring or a window shape like that. So to find the area of the side, this rectangle, when we lay it flat, well, it's going to be the length of the cylinder still. So it was 3 centimeters long here, or 3 centimeters high, however you want to think of that. So this is still 3 centimeters right here. And then this part right here, this would have been the part that wrapped all the way around, or in other words, the circumference of that circle. So how do we find circumference? Just like we said yesterday, we just go pi times diameter. Okay, and when it comes to circles, formula for finding area of circles is just pi times radius squared. So we've got our formulas there. So let's start filling in some more information. All right, so because we are talking about both the top ring that we see and the matching bottom, that means whatever calculation we do to the top, let's make sure that we double it to also account for the bottom. So 2 times whatever calculations we do. Now instead of just going ahead and doing pi r squared, we're going to have to find, yes, the area of the big circle, but from that we're going to have to subtract the area of the little circle that we're missing here. So we'll have to find the area of the big circle minus the area of the little circle. Just doing big minus little to have less to write here. Okay, so how do we find area of a big circle? Well, any area of any circle is pi r squared. So that means that we'll do pi times the radius of the big circle. So I'm going to use a capital R to represent that. squared minus area of the little circle. So again, it'll be pi times radius, but this time it'll be the radius of the little circle. So I'm going to use a lowercase r to represent that, squared. So I'll fill in some more information here. 2 bracket 3.14 is our approximation for pi times the big radius. So the big radius, well, we're not given that. However, we are given the diameter of the big circle. So if the diameter is 6 centimeters, well, radius is just half of that. So 6 divided by 2 gives me 3. So that would be my radius right there. So 3.14 times 3 squared minus pi 3.14 times my little radius. Well, I'm not given the little radius, but I am given the diameter of the little circle. So again, if I have the diameter, all I have to do is divide that number by 2 to get my radius. 2 divided by 2 gives me 1. So times 1 squared. Okay, so make sure I'm doing proper order of operation. So that means dealing with what's in the brackets first, but then on top of that, dealing with the exponents first. So I end up with 3.14 times 9, 3 times 3 is 9, minus 3.14 times 1. Okay, next will be the multiplication inside the brackets. So if I type into my calculator 3.14 times 9 equals 28.26 minus 3.14 times 1, well, anything times 1 just stays the same. Okay, so now last operation in my brackets is subtraction. 28.26 minus 3.14 gives me 25.12. And last thing, that's the area of the top ring, but I need to double it to also account for the bottom. So then I do 25.12 times 2, and it comes out as 50.24. So that takes care of the top ring and the bottom ring. Now, for the side, the wraparound curved side part, which if we lay flat, like we already said, is just a rectangle. Formula for a rectangle, length times width. So the length stays the same. The length of this cylinder is still going to be the length of this rectangle times the width. That's the circumference. That's the part that wraps all the way around. So times pi times diameter. So let's fill in some more information. 3 times 3.14 for pi times the diameter of the circle that particular rectangle is wrapping around. So it's wrapping around the big circle. So that means we need the big diameter, the big circle's diameter. So that's 6 times 6. Okay, and because it's multiplication, that's all multiplication, I can put it into my calculator all at once. 3 times 3.14 times 6. And it comes out as 56.52. And notice I'm just bringing it right down here beside my other calculation so that I can keep track of it. Okay, so those two numbers added together account for the two ring surfaces and the whole red wraparound part, rectangular part. But, like I said when I started this video, the one thing that makes this tunnel shape different is I have created a little bit more surface area by cutting a tunnel straight through here, and that would be this curved part rolled up on the inside. So if we were to make a cut and lay that part flat, again, we would just end up with a big long rectangle. So the length of that is still the length of the cylinder. So this cylinder is 3 centimeters long. Tunnel runs all the way through, so that's also 3 centimeters right there. And the width of it is the part that wraps around the circle. So the part that wraps around, in this case, the little circle right here. This circumference right here becomes the width of it. So again, I'm going to be using pi times diameter to find the circumference. Okay, so again, formula for finding area of a rectangle is just simply length times width. My length, like I said, is still just the length of the cylinder, so 3 times the width is the circumference. Once I unroll that and lay it flat, that becomes the width. So 3 times pi times d, so 3 times 3.14 times the diameter, and in this case, because it's the circumference of the little circle that I'm looking for, that means I'm using the diameter of the little circle. So times 2. Okay, and again, because it's all multiplication, I can just go ahead and enter it all in my calculator at once. 3 times 3.14 times 2 equals 18.84. Okay, so there's the surface area on the outside of this tunnel shape. There is the surface area on the inside. So my very last step is to just add it all up. So if I go 50.24 plus 56.52 plus 18.84 in my calculator, what do I end up with? One 25.6, and my original units were all centimeters, and of course I am talking about area, so it's got to be centimeters squared. Okay, box it up, nice and neat. Final answer. Alright guys, that's it for this video. Thank you so much for watching, and I will see you in the next one.